Hello and welcome back to the Cracking FAANG YouTube channel. Today we are solving one of my least favorite questions. This problem is extremely annoying to code up, and even though it's not that hard to solve conceptually, it's just a horrible problem that requires way too much work to do. Okay, it is 670 maximum swap. You are given an integer num. You can swap 2 digits at most to get the maximum valued number and return the maximum valued number you can get. So let's look at an example, 2736. So what is the maximum swap here? Well, we can see that actually if you swap the 7 and the 2, you will get the number 7236. And there's actually no number we can make that's larger than this because 7 is the largest number here. So putting it in the front would give us something in the 7,000s, and there's no other possible combination we could do here to give us that. And then here we have 9973. There's nothing we want to swap because 9 is the largest digit we have, so we wouldn't want that to get rid of it in the first position. Same with the second position, 9 is the greatest digit, so there's no reason to get rid of that. Again, 7 is the next largest digit, and then 3 is the next largest digit. So there's nothing we can do here. We just leave it as it is. Okay, this problem, if you're just looking at the actual input, it's really easy for your brain to just figure out what the biggest swap is because you can kind of just do it in your head. You just take whatever the biggest number is, swap it with whatever the smallest number to the left of it is, and you're done. Unfortunately, while that's the general intuition we want, is like find leftmost, smallest num, and then we want to swap it with the rightmost, with the number to the right of it that's actually the biggest. So rightmost largest, wow, my handwriting sucks, largest number. Actually executing this is a massive pain in the ass because you just have to do so many things in this problem. But instead of actually going through kind of the intuition here, because I mean, generally this is what you want to do. You just want to find the leftmost smallest number, and then whatever the largest number to the right of it is, you just want to swap it with that. So essentially that's what we want to do. It's just actually how you do this and keeping track of those positions. That's the annoying part. There's not really too much you need to know for the intuition. You just need to know how to actually execute and write the code. So instead of kind of going over iteration by iteration, let's just go to the code editor and actually write this up because it will be a lot clearer. And there's a lot of extra steps that we need to do, unfortunately, to get the solution here. Anyway, that's enough rambling. I'll see you in the code editor momentarily. Okay, we went over the basic intuition for this problem. Now let's actually code it up, and you'll see just what I mean when I say this problem is a pain in the ass. The first thing to realize is that if our number is actually less than 11, then it's either a digit, the number 10, or 11. In all those cases, that's actually the largest number that we can get, and we actually don't need to swap anything there. So we're just going to do a quick little thing that says if num is less than or equal to 11, then we can actually return the num. This part, I guess it's not really necessary because the logic will take care of it anyway, but whatever. The next thing we want to do is we realize that our number is an integer. And we obviously can't swap things by index in an integer. So we need to take our number and actually transform it into a list where each element is actually the digit. So we have an index that we can swap with. So what we need to do is we need to basically just put this into an array. And what we're going to do is we're going to do num as array is going to equal to collections.dec and an empty queue. And the reason that we're going to use a queue is you'll see in a second. So we're going to say while num, we're going to say num as array dot append left num modulo 10. So we basically need to extract all of the digits from num. Now doing num modulo 10 will actually give us the rightmost digit, but if it's a list and we append, then when we get our final list, it will actually be in the reverse order because we get the rightmost element first and we keep appending. So that's why we use a dec, because we can actually append to the left in constant time and we don't have to actually waste one pass through our number to actually reverse it because it will be in the wrong order if we just use an array. As you can see, this problem is annoying. So after we have appended the rightmost digit, then we need to just decrease it by a factor of 10 each time until num basically is 0 and this while loop ends. So for example, if we had 1, 2, 3, 4, if we were using an array, we would get the 4 first, append it, the 3 first, then append it, 2, and then 1. Obviously that's the wrong order, so we need to reverse it. Whereas if we use a deck, we can just put 4 and then we can append to the left, so 3 here, and then we can append the 2, and then we can append the 1. So it saves us actually having to reverse it. So that's just one pass through that we save. Okay, we now have our number as an array. Now we can actually work with something. So remember that we want to keep track of the maximum number that we've seen and where we see it, because we'll have to swap that with basically the smallest number to the left of it. So what we're going to do is we're going to say the maximum seen is going to be -1. We haven't seen anything yet. And we're going to say that the maximum seen at is going to equal to, well, basically the length of the array, because we haven't processed anything yet. So we are going to actually go from right to left, because we want to keep track for each element what is the largest element to the right of it. And once we have that information, what we can do is then go from left to right and actually swap with whatever the smallest element is. Again, extremely annoying. So what do we want to do? We want to basically go from right to left over our array. So we're going to say while I is greater than, oh, sorry. Yeah, I forgot to set I. So I is equal to the last element in the array. So num as array -1. Then we want to go backwards. So while I is actually greater than 0, we're going to say that the current number is going to equal to num as array of I. Now what we want to do is we want to override our num as array, and we want to store some extra information at each index. So we're going to say num as array of I. We're going to store a tuple, and it's going to contain a few bits of information. We want to still keep whatever the current number is, and we want to keep whatever the maximum to the right of it is, and whatever the index that was seen. That way, when we go back from left to right, we can actually do the swaps for each element. So we're going to say whatever the maximum seen is and the max seen at. Now what we want to do is we actually want to update our maximum seen in case that our current number is actually the maximum. So we're going to say if the current num is actually greater than the maximum seen, then what we want to do is maximum seen is now the current number, and the maximum was seen at our current index. Okay, the last thing we need to do is obviously decrement our while loop here to make sure that we don't get caught in an infinite recursion, and that will basically parse through and for each element set the current number, whatever the max was seen so far coming from the right, and whatever the index is. Now what we can do is we can actually go from the left and basically do the swap. So we're going to say that I is now 0, and we're going to say while I is less than the length of the array, length of num as array. Now we're going to go from left to right, and we're going to say that the current number, the max to the right of our current number, and the maximum was whatever it was seen at is num as array of I. So those are the new elements we have at each index here. Now what we want to do is we want to actually decide whether or not we want to make the swap. So we're going to say if the max to the right of our current number is actually greater than our current number, then this is the swap we want to make, right? And the reason we're doing this is because we're starting at index 0. So basically, we want to take the very first element that's smaller, that has a smaller number later on. We take the smallest element that we see. Remember, so if the thing was like 2374, then the smallest element to the right of 2 is obviously going to be the 7. So we take whatever. Okay. As you can see, this problem is annoying. We have 2374. The largest element to the right of our 2 is going to be the 7. So we want to just swap it immediately when we do it, and we'll actually do 7324. So as soon as we get an element that's smaller than whatever the maximum seen is, then we just make the swap. So that's the reason that we go from the left, because we want to get that smallest element on the left side and swap it with whatever the maximum element is in our array. So if we hit this condition that the maximum to the right of our element is actually greater than the current number, then we make the swap. So we're going to say num as array of I, and we want to swap it with num as array of whatever the max was seen at, and we want to swap these two. So we're going to say num as array of max seen at. I want to swap with num as array of I. So we basically do the swap. And then at this point, we're done because we can only swap one time. So we simply break out of our loop and we're done. Otherwise, if this condition doesn't hit, then we need to keep going through our array to basically just parse further. So we can just I plus equals to 1 here. Now our while loop will either break because we broke manually, or we will hit the end of the array, which means that we are basically done. Unfortunately, and this is where this problem is annoying, we need to return an integer. So we now need to take our list, which contains the elements, and turn it back into an integer, undoing what we did here, taking it an integer and making it a list. So now we have to go through our array one more time. So we're going to say for the current number, we actually don't care about the other things because they're not going to be useful for us anymore. In num as array, we now need to reconstruct our integer here. So we're going to say num equals to num times 10 plus whatever the current number is to basically reconstruct the value there. Okay, now we have reconstructed our value. We can simply just return num, right? Oh, sorry, we actually need to define num. So num equals to 0. So num is our result in this case. Okay, let me make sure I haven't made any syntax mistakes because this problem is beyond annoying, and accept it. Okay, cool. I was expecting to get some recursion issue. All right, submit it, and we can see that it's accepted. Okay, thank God we are done with that. What is the time and space complexity here? So as you can see, all we do is go back and forth through our array some number of times. So the time complexity here is just going to be big O of n. What is n? N equals the number of digits inside of num, right? Because that is how long this num as array will be, right? Because however many digits are in here, that's how many times, that's going to be the time complexity. We're really just looping over an array from back to front a few times. So it's really just a string of big O of n operations, but asymptotically, we know that it's just big O of n. For the space complexity, again, we are just storing an array, which basically stores each digit. So this is going to, again, depend on how many digits are in num. So that is really it. We have, multiple big O of n storages here because we need to basically just have the array and then we override it with these things. But again, it's just big O of n. So that is your solution. In this time, it's big O of n. In the space, it's big O of n. As I said in the beginning, this question isn't that hard. You're just basically taking a number, making it into an array, iterating over that array from right to left, and then from left to right, and then just iterating over the array. Technically speaking, nothing in this problem is that hard. It's just actually going through the process and making sure you don't mess anything up. And it's not a technically hard question. It's just annoying to code up, and you can definitely make a lot of bugs. There's probably places you can optimize. Obviously, I did the using a queue here to optimize. You can probably not do the second while loop in the case that there is no swap to be made, but let's just not make it more complex than it needs to be. This is already the most optimal solution. So yeah, that's how you solve maximum swap. Like I said, one of my least favorite problems, just because it's so annoying to code up. It's really annoying to explain. I even got tripped up a few times, and I've done this problem like a dozen times. Anyway, hope you enjoyed the video. Hopefully you suffered through it with me, and why not leave me a like and a subscription for explaining this god awful problem to you guys. Anyway, thanks so much for watching. I will see you in the next one. Bye.